Hi, Mrs. Hassler here. Today I'm going to give you notes on 2.6. We're going to be solving equations and inequalities with variables on both sides, okay? So adding another layer to this. So I'm going to go through an example with you. I'm going to write down that checklist of steps we need to be thinking about as we go through the process of solving. We're going to do some graphing, and then today we're going to talk about checking your solution to make sure that it is the right solution. Okay, so the first thing I like to do when solving is I like to draw a line down my paper underneath the inequality symbol to separate that I have two different sides I'm working with, okay? And when solving, the first thing I should look for is the distributive property. Distributive property is when you have that group of parentheses, a number directly in front, and you would multiply that number to each term inside the parentheses. I have no parentheses here, so I do not need to use the distributive property. The next thing on my list is to check for combining like terms. Combining like terms is referencing what's happening on just one side of that inequality symbol. So to the left, I have 2x plus 6. Those are not like terms. I cannot combine them. To the right, I have 5x minus 3. Those are not like terms. I cannot combine them. So I move on to the next step, okay? The next step is the new layer. My next step is to look at my problem and say, well, my job is to isolate x. I have two x's. So I either need to get rid of the 2x, okay? So I only have x on the right-hand side, or I need to get rid of the 5x, so that I only have x on the left-hand side. And no, I cannot actually get rid of them by just scratching them out, okay? So we have to do some math to eliminate. That's our next step. We're going to eliminate a variable on one side. It does not actually matter which variable you eliminate. Some people have strategies like wanting to keep the number, the coefficient of x positive, or some people like to solve so that the variable is always on the left side. It does not matter your strategy, okay? If you do everything accurately, we will get the same answer. So I like to work so that I have everything to the left side. That means that I want to get rid of this 5x so that I have x just on the left side. It's a positive 5x. So I'm going to get rid of it by doing the opposite and subtracting 5x. Okay, so 2x minus 5x is a negative 3x. I still have plus 6 greater than, well, 5x minus 5x is 0, and I'm left with this negative 3. Okay? Now look, I have an equation or an inequality in this case that I should be comfortable solving. Right? My next step is typically to undo the addition or subtraction. So I would, in order to isolate this x, right? That's the goal, is to get x by itself. I would subtract 6 on both sides. I have a negative 3x greater than negative 9. My next job would be to undo the multiplication or division. So I'd want to divide both sides by negative 3. Okay, negative 3 divided by negative 3 is 1x. Negative 9 divided by negative 3 is 3. Oh, look, I divided by a negative number, which means I need to flip my inequality symbol, okay? And so that's my last piece of advice for you here. It's just a little recall. When you flip the inequality symbol, if you're multiplying or dividing by a negative. Okay, so now my job is going to be to graph this. So I like 3 numbers on the number line. I've got 2, 3, 4. There's no equal bar here. It says x is less than 3. So it's an open circle with no equal bar there. I could do some test points to make sure I draw my arrow in the correct direction. And I just like to use the test points that are on my number line. We'll go with 2, okay? Is 2 less than 3? Yes, 2 is less than 3. So my arrow should move to the left, covering all values that are smaller than 3. Okay, then I want to check this, all right? So to check this, it says substitute back into check your solution. What that means is I'm going to take this answer of 3, and I'm going to replace the x in the original inequality with the 3. So I've got 2. I'm going to replace the x with 3 plus 6 greater than 5 times, I'm going to replace the x with 3 minus 3. And then you could type this in your calculator. You could do mental math, right? 2 times 3 is 6 plus 6 is 12 greater than. 5 times 3 is 15 minus 3 is 12. Okay. So I know I got the right solution because I had the same number on either side of that inequality symbol. I know that the value for x should relate to 3 because when I put 3 back into the original inequality, I got the same output on either side. Okay? It does say 12 is greater than 12. And I know that 12 is not greater than 12. It's equal to 12. 12 is equal to itself, but it's not greater than itself. So, that's the reason why we have this open circle up here. The solution of 3, when I substitute 3 back into that inequality, that solution does not give me a true statement, but it does yield the same output on either side. That's why I have an open circle, because 3 is not part of my solution. However, any number less than 3 would be part of this solution. So for example, if I were to put 2 back into this equation, just like I did with that number 3, and I evaluated that, let's see, 2 times 2 is 4 plus 6 is 10. 5 times 2 is 10 minus 3 is 7. Look, when I chose a number within the region that arrow was moving and substituted it in, I got a true statement. In fact, any number in the region of that arrow we draw, if I substitute that back into my inequality, the original one, I should get a true statement. Okay? Okay. So, we're going to go ahead and do a couple more examples. We're going to solve each equation or inequality in graph. Then we're going to substitute back in to check our answer. So again, I like to draw that bar. Okay? Now, I had mentioned in the other example that it doesn't matter how you approach eliminating the variable. Right? There's no distributive property here to use. There's no combining like terms. Okay? So the next step is to eliminate x on one of those sides. My last time my strategy was to keep the x on the left side. I just want to show you what happens if you choose to keep the x on the right side. Okay? It doesn't matter which variable you get rid of as long as you do it mathematically correctly. This is positive 5x. So to get rid of that, I'm going to subtract 5x on both sides. I chose this way for another reason. Look how strange this is. This is 5x minus 5x. Hassler, that's 0. I know. And this throws people because they're like, but it's 0. What do I write? 0. Okay. 0 is treated like every other number, and I can't be afraid of it. All right, so now I have greater than or equal to. Negative 3x minus 5x is a negative 8x. Then I have minus 16. And now I'm down to that two-step problem I should feel more comfortable with, right? I'm going to add 16 on both sides. Look, I just have 0 plus 16. That's 16, okay? Greater than or equal to negative 8x. Divide both sides by negative 8. So that gives me x here, negative 2 on the left. Oh, and look, because I divided by a negative on both sides, I have to flip my inequality symbol, okay? So I'm going to go ahead and number the numbers on my number line. Remember when you have negative numbers, You have to pay real close attention to how you're labeling that number line. Because there's an equal to bar, I'm going to have a closed circle. And again, I can pick some test points to determine what direction I should draw my arrow. Okay? I'm just going to pick numbers on my number line. So I'm going to put it back into this solution just to check how to draw my arrow. Is -2 less than or equal to -3? No. So I would not want to draw my arrow to the left. Let's just check the -1. Is -2 less than or equal to -1? Yeah. So for that reason, I would draw my arrow to the right. Okay? But again, I want to check to make sure that -2 is actually the right answer. Like, did I go through this process and get the right number associated with x? So in order to do that, I would take my original inequality, 5x. Well, in place of x, I would put the number I found associated with x, -2, okay? Greater than or equal to -3. Replace the x with a -2 minus 16. Okay, and again, you can type this in your calculator, do some mental math. I get -10 greater than or equal to, let's see, -3 times -2 is 6. 6 minus 16 is -10. Hey, look, I got the same value on either side. Oh, and also look, -10 is greater than or equal to, it's equal to itself, which is why I have a closed circle on my number line at -2. Okay, -2 does give me a true statement when I substitute it in. And you could always check numbers bigger than -2. If I put numbers bigger than -2 back in for x, I should still end up with a true statement, just like we checked in the example. Okay, let's do this last one here, a little more involved. Again, I like to draw my line. You're not required to do that. It's just helpful for some. And remember, the first thing I look for is the distributive property. So when I distribute, I get 3x plus 12 minus 2 equals 5x plus 6. I look for like terms to combine. On the left side, I have like terms to combine, 12 minus 2. Okay, so I get 3x. 12 minus 2 is 10 equals 5x plus 6. Okay, again, I have an x variable on each side of this equal sign. My job is to eliminate one of them. It does not matter which one you eliminate, okay? I like to keep it so my variable's on the left-hand side. That's just me personally. Other people have different opinions, okay? 3 minus 5 is a -2x. I still have plus 10 equals 6. And now I'm down to those typical steps, right? Subtract 10, subtract 10. I get -2x equals -4. Divide both sides by -2. Not a space, sorry. X equals 2. So 1, 2, 3. Because this is an equation and not an inequality, we just put a closed dot on my solution on the number line. Okay? And the last thing I want to do is check. So again, when I go to check, I write out this original equation, 3 parentheses. In place of x, I'll put the value that I got, and then plus 4 minus 2 equals 5 parentheses 2, and then plus 6. And again, I can just type this in my calculator exactly the way I see it. When I do that, I'm going to get 16 on the left. If I type 5 times 2 plus 6 in my calculator, I get 16 on the right, which means that x equals 2 was the correct final solution. Your job is to finish this paper. Good luck.